Hi, I'm Marti McCurdy with Spirit Electronics, and I'm here with Alex Lidow from EPC. How are you, Alex?
I'm doing great. Thanks so much for coming.
Thanks for having me. So we're here at the EPC factory here in El Segundo, California, and we just wanted to talk a little bit about the GaN products for power conversion that are on the market right now, and you're the man to discuss that with, since you're the founder here at EPC. So if you could give us a little bit of your background, that would be awesome.
Well, I've been in the business now for 40 years. We started EPC 10 years ago, but before that I was at International Rectifier, where I was involved in the early developments of power MOSFETs back in the late 70s, and I wound up being the CEO there for about 12 years before I founded EPC.
I see. And when did you found EPC here?
2007, and our first products were launched on the market in 2010.
Can you maybe just give us a little highlight on why GaN is taking over the industry as opposed to the CMOS and power conversion?
So, silicon's been dominant technology in semiconductors for 60 years now, and gallium nitride is an expensive material, but about 19-20 years ago, researchers in Japan figured out how to grow gallium nitride as a very thin layer on top of silicon. What that meant was that you could use all the same equipment that you use to make silicon devices and use it to make these gallium nitride hybrids where an epi layer on top of silicon. But gallium nitride can make devices that are 6,000 times more efficient than silicon.
It's a big number.
It's a big number. We haven't harvested all of that yet, but we're harvesting a lot of it. So we were able to get the cost structure of making the silicon device, but the performance of something that's a whole lot better. And so for the first time in 60 years, we can make devices that are higher performance and lower cost than silicon in power conversion.
Nice. Well, I know from our customer base that are launching satellites and things into space, payload is a big issue. So I think just from a sheer size and weight factor, that's a big advantage over GaN. So is there a comparison there that you have from typical CMOS down to GaN that's in a weight factor?
So in a satellite, there are many factors that add to weight. One of the heaviest things are the solar panels. So if you can get the energy from the solar panels to the business end of the satellite more efficiently, you can save a lot of weight there. So first and foremost, gallium nitride is a more efficient conductor of electrons. So you can make more efficient power conversion from the solar panels into the satellite systems themselves. Secondly, gallium nitride is much smaller and lighter weight than silicon as a result, and therefore you can save that space as well. Third, you can go to higher frequencies of power conversion, and that means that all of the peripheral components, like very heavy magnetics and capacitors, also shrink. So you get higher efficiency and smaller size at the same time. In some applications, one of the most important things is if you're in a radiation environment, the shielding adds a lot of weight. And gallium nitride does not have those elements that are sensitive to radiation that you have in a MOS device. So it is naturally radiation tolerant as a result, and so you can make very, very efficient satellites that are in either geosynchronous or interplanetary applications.
Nice, very nice. Well, it all starts with power, right? I mean, everybody seems to build maybe around an FPGA, but at the end of the day, it's all about the power that's coming into the board and weight and payload. So the magnetics and inductors, if we can reduce those sizes, I would think that's a huge advantage for the military and space applications.
Absolutely.
So I know one of the big factors in the industry right now, especially in GaN, is your LiDAR. So I think that you're kind of leading the edge in that application. If you want to talk about that a little bit, I think it's fascinating for one, and it's kind of the cutting edge of what the industry is doing right now.
LiDAR is a really cool application. I didn't know it even existed. But this gentleman, Dave Hall, who's CEO of Velodyne, he came to us maybe about 6-7 years ago. He said gallium nitride would be perfect for this thing I'm building that measures the time of flight of light. That seemed like a crazy idea to me.
Right.
And he needed it for Google mapping cars because they wanted to digitally map the world. And it turns out it became applied to things like autonomous vehicles. But then reading the history, the first LiDAR application was landing people on the moon.
Is that
to actually decide how far the lunar excursion module, LEM, was from the surface of the moon. And the problem with LiDAR over all these years was measuring the time of flight of light is hard, and you have to be very fast to do it.
Sure.
And silicon isn't fast enough to do it very well, so it would give you very poor resolution. And so systems like radar systems became more popular, like in cars and even in a lot of satellite applications where there's docking and things like that. But with gallium nitride, we can get LiDAR so precise that you can measure, you can measure the mole on the end of your nose if you want at 150 meters. And it's all about speed in that case.
Yeah, no, that's incredible. I've seen some of your app notes on your website that show actually a previous image and a GaN image on the digital display. It's as if I don't have my contacts in, right? When you look at it, it's so clear.
Right.
So yeah, I can imagine in the industry, especially in the military, if we have this kind of visual, what kind of effects that could have on increasing our night vision goggles and some of the battlefield applications that might exist, and especially for speed,
Yeah, I mean, I've seen one fantastic demonstration where a LiDAR system was mounted on a drone that was flying over an operating theater, and because it gives you a digital image that's XYZ coordinates, it's very simple to translate it into the person on the ground's point of view. So you can fly these drones over a theater of operation and then have these goggles where the person on the ground is actually seeing what's in front of them that they wouldn't normally be able to see.
Right, yeah. I can appreciate the weight of some of the packs that these guys handle, and we saw an application for one of our recent customers that we'd love to introduce the EPC products to, where they had one eyepiece on their helmet, and they had a scope mounted, night vision scope mounted on their rifle. And let's say that this was the corner of the building, they were able to put their rifle out here, get a vision of people standing around here that may be enemy combatants, and they could see it and not expose themselves to the target range. So I can imagine the clarity that a product like the EPC products could bring to that kind of vision. So it's endless, right?
Yeah, you bring up the soldiers who are carrying these 70-pound packs,
Right.
and a lot of that now is batteries. And so there are companies, and there are a few really cool applications that are using wireless power so that you can use a single battery pack and power all the gadgetry that way, and then that wirelessly powered system can be wirelessly recharged from the transport vehicle. So soldiers can reduce either their payload, or they can carry more, weaponry or whatever it is.
Yeah, and I know that just we've had some discussions with your applications engineers on some mutual customers that are doing wireless power, and from a basic user standpoint, nobody can live without their phones now, and so having a coffee shop that you walk in and you can immediately charge all your devices, or I'm a huge Tesla fan, so pull in my garage and charge the Tesla without plugging in. All of these ideas are fabulous, and I see EPC on the leading edge of supporting all of that.
Absolutely, and you take wireless power even one step further. There's one company that's building wireless chargers for mid-air recharging of drones. And again, it's a military application. It's so that the drones can be flying over the transport vehicle, because you can't land a drone on a moving vehicle.
Right.
It would just bounce off. So they hover around it and get recharged, and then they can be sent off to do forward observations.
Wow. That's exciting, isn't it?
Yeah.
I mean, I think really if you look at the military and some of the space activities that are going on, I think your imagination is almost limitless now, right? And bringing something in like the power conversion devices just makes it more reality for me. So I think we're living in the Jetson age, right, where everybody's creating something very unique. So, any other thoughts, or where's your 5-year program going forward with EPC? What are your thoughts there, if you can share that?
So, gallium nitride, as I said, is 6,000 times more efficient than silicon in power conversion. What that means is you can make a device 6,000 times smaller than silicon. The problem you have with that is you can't get the power in and out of something that small. So we've got to devise new, novel ways of handling that. And the best way is integration. Silicon power devices don't integrate well because power devices interact with each other.
I see.
It's not true for very, very small logic devices. But when you get into power, they interact. So you don't see monolithic silicon power systems. You always see a lot of discrete silicon devices and a bunch of ICs that are low power talking to the silicon devices. But with GaN, you can integrate it. And in doing that, you don't have to get the power in and out of each of those devices. You can get the power in and then communicate it in a more efficient way in the sub-levels of the integrated circuit. So if we want to harvest the full 6,000 times better than silicon, we're going to see full power systems on a chip. And EPC's already started doing that. You can see around us, there's some examples of integrated circuits. That one, there you go, where we've actually started integrating the driver functions onto the same chip as the power GaN device, all made in GaN. So it's rad tolerant, and it saves a silicon component. Oh, by the way, silicon is slower than GaN, so the silicon is really slowing the GaN down anyway. So now we get speed, we get economies of size and economies of cost, and now the rad tolerance is also the same as GaN.
I think one of the things that was enticing to us as your distributor is that you're very open on your designs. So you have eval boards for almost every one of your product lines, and that's available along with the Gerber files and everything else for the customer to be able to build out their own design. I think that's very forward thinking.
Good, thank you. Yeah, we try to make it easy because when a designer comes up with a very new technology like GaN, it can be daunting. So we try to have demo boards and development kits that really get it going so that you get your design done, even though you're dealing with a whole new technology.
Yeah, much appreciated. Well, thank you, Alex. I appreciate your time today. Is there any closing thoughts from your side?
Well, I very much enjoyed it, and thank you so much. We also, at EPC, we spent a lot of time educating engineers, and so you can see we've written several textbooks that are used around the world, and we have both applications teams all over the world and field applications engineers, so that we hopefully can get technical help to anybody who needs it right away.
Yes, these are great, and they're available on your website, and also all your app notes and some excellent videos are on your website as well, so I think it's a useful tool. You've done well with that.
Thank you very much.
Great. Thank you, Alex. I appreciate it.
Me too. Thank you very much.